So for my test wrapper, I wanted to review problem 4, specifically part B, because that was the one that I had, I think, the most trouble with on the exam. So here we are going to use the same approach and use Gauss's law for electric fields. And so I've written part of the equation here from my exam, but specifically for part B, we know that Gauss's law is going to be over the entire surface. And we know that that equals Q enclosed over epsilon naught. And because we know that this is for all the faces, we can actually say that sorry about that, E times N times the area is equal to Q enclosed. Looks like something funky is happening with my pen. So now that we have this, we're going to start with the left side. So, just doing that funky thing again. So, here we know for the left side, we know it's going to be equal to dA. And because we found it up here, we know that E times N dA is just going to be 0, 500, 0 times -1, 0, 0. And that gives us the electric field of 0 for the left side. So now for the right side, I'm going to just label it right. And here we have a little bit of a different story. We have N going in the positive X direction, but we also have X equal to 0.07 here, as you can see. So that gives us E times N I dA, and that's equal to -7, 500, 0 times our N vector. And then we also multiply that by 0.04 times 0.03, and that gets us, doing the math, 0.0084 voltmeters. Okay, and that makes sense, so we're going to move on to top. And here again, we have to divide it once more. So N is in the positive Y direction, and our X is between 0 and 0.07. So we know that for the top, we have -100x 500 0 times 0, 1, 0 dA, and that's actually going to give us 500 dA. We can pull out the 500 because it's a constant, and we end up getting 1.05 voltmeters here. Okay, moving along swimmingly to find the bottom electric flux. We know that N is in the negative Y direction. We also know that it's between, our X is between 0 and 0.07, and so because we know that this is just going to be the opposite of what we actually just calculated, we know that for the bottom, it's going to be -1.05 voltmeters. So that was quick. Now we can move on to the front. And we know that our n is just going in the z direction. Now from the question above, told us that actually nothing was coming from the z direction. So we already know that that flux, the front, is going to equal 0. We don't even have to set it up. Lastly, for the back, we know that n is going in the negative z direction, and again, we don't have to set it up. We know that that is going to be equal to 0. So when we're finding Q enclosed, first we have to find the total fluxes of the entire system. And so we know that Q enclosed is just going to be epsilon naught times everything added up, right? So 0 minus 0.0084 plus 1.05 minus 1.05 plus 0 plus 0. Now we can cancel out 1.05. We don't need the zeros, so what we end up with is actually Q enclosed being equal to negative 7.43 times 10 to the negative 14th, because we know that this is a known constant with a value of 8.85 times 10 to the negative 12. This is our final answer. Thanks for watching.